Dear students, today we are going to explain the reflection of light, and also we are going to prove the laws of reflection using the Huygens wave principle. Well, you see here we have considered light as a wave and is represented by its wavefront. Now here we have a plane wavefront. We have assumed that ADB is a plane wavefront, and if you think in terms of rays, then that is at 90 degree to the plane of wavefront, which is represented by the arrow. Different rays, 3 rays we have considered. Now if this is the incident wavefront, plane wavefront of the light, which is incident on a plane mirror M1, M2. After reflection, it is moving in such a way that we have assumed that A1, B1 is representing the reflected wavefront. Now this assumption will be held true only when the ray which is somewhere in between the wavefront reaches point D1 in the same time. In what time the ray reaches from point B to point A1, or from point A to point B1. Because medium is same, so the light will have the same speed, and therefore the light will take same time to reach from A to B1 as it takes time to reach from B to A1. So the time taken by light ray while it reaches from A to B1 must be equal to time taken by light rays while it reaches from B to A1. So that will be the true wavefront, only reflected wavefront, only when somewhere ray in between must also reach the same wavefront in same time, and that will be proved only if the length dP plus PD1 is equal to BA1 equal to AB1, because all the light rays are traveling with same speed, so their distance traveled in same time must be also equal. So this we have to prove to prove our point that our assumption A1, B1 is representing the reflected ray in true sense. And also we shall prove that angle of incidence is equal to angle of reflection. What is angle of incidence? You all know, angle made by incident ray with the normal, and that angle is nothing but angle made by wavefront with the mirror. How you come to make this concept? We have already learned that angle between two lines is always equal to angle between their normals. So here you see angle between two lines, that is incident ray and the normal. If this is angle of incidence, then angle between two lines, incident ray normal, is equal to angle between their normals. So wavefront is at 90 degree to the incident ray, so this is the normal of incident ray, and mirror is at 90 degree to the normal, so this is normal to the normal on the mirror. Therefore angle between two lines, normal and incident ray, must be equal to the angle between their normals. This is the normal of incident ray, and this is the normal on mirror. So this is representing I. Similarly, we can have angle of reflection equal to angle between reflected wavefront and the mirror. If we prove that I is equal to R, that means angle of incidence is equal to angle of reflection, then the laws of reflection will be automatically verified. So now let us make a construction here. We draw a line PN which is perpendicular to line BA1, so that DB and P becomes a rectangle, and if that becomes a rectangle, we have BN equal to DP. So we can write BN equal to DP, and we have just discussed that AB1 must be equal to BA1, so we are taking it to be equal. Now since light is traveling with a speed c, then in time t it will travel a distance BA1 is equal to CT is equal to AB1. So we represent it by this relation CT. Now from the RHS congruency, what you see that triangle AA1B, triangle AA1B is congruent to triangle A1AB1, triangle A1AB1. So we have these two different triangles. And another is this is I am drawing these two triangles separately so that we have better understanding. And another triangle is AB1, AB1, A1. What you see is these two triangles are congruent. How? This angle B is 90 degree, angle B1 is 90 degree. Angle, here you see the side AA1 is common in both. This is RH right angle triangle, one side is common, angle is 90 degree, and another sides are also equal. See, AB1, side AB1 is equal to side BA1. Therefore, it becomes a congruent triangle. You see, AA1 is common, one angle in 90 degree in both the triangles, and another side are also equal. This one, side AB1 is equal to side BA1, and therefore it becomes a congruent triangle. And from that we have, from the congruent triangle, you see the angle opposite to the equal sides must be equal. So here you see the angle opposite to side BA1, angle opposite to it is angle I. So this is angle I. And angle opposite to AB1 is angle R. So these two angles become equal. That means angle I is equal to angle R is proved. Here equation number 4. Now we also have PN is perpendicular. We have drawn like this. PN is perpendicular to DB. So that means this is a rectangle and BN must be equal to DP. So we write BN is equal to, we write here BN is equal to DP. We have already discussed earlier. Now BN is equal to DP. BN is equal to DP. Now if you use these two relations, one more thing we have to see. Therefore we get BN is equal to DP, and from AAS congruency triangle NPA1 you have to hold this in your mind. Then we consider another congruent triangle NPA1. Here you see NPA1, the smaller triangle, is congruent to triangle D1A1P. D1A1P. So these two triangles are congruent. How? Let us see. Angle N is 90 degree, angle D1 is 90 degree. PA1 is common to both. And again this would be RHS congruency. And so, one angle is 90 degree, another is 90 degree. So two angles 90 degree. One side is common, PA1, and what you see is, we have already proved that angle I is equal to angle R, but this angle NPA1 is nothing but the corresponding angle. So this is also I, and I is equal to R, therefore these two angles are equal. So two angles are equal, so third angle will be also equal, and therefore it is angle side congruency, and therefore we have now, you see, to have a better insight, I draw it separately. I draw the two triangles separately. I will suggest all of you to keep this in practice, because that avoids any confusion. Here you see one triangle is PA1N, another triangle is PA1D1. Now here you see this angle is I, and this angle is R. Both are equal, we have just proved, equation 4. And this angle is 90 degree. So third angle must be also equal. And now sides opposite to the equal angles are also equal. Sorry. Therefore we can have NA1 is equal to D1P. NA1 is equal to D1P. Angle opposite to the angle I, angle opposite to the angle R. Sorry, side opposite to the angle I and side opposite to the angle R must be equal. That means NA1 is equal to D1P. So this is our equation number 5. Now using these two equations, equation number 5, that is NA1 is equal to D1P, and also using the equation number 3, that is Bn is equal to dP, we have this equation rewritten as dP plus PD1 equal to, for dP plus PD1, for dP we have Bn. So we write it Bn for dP, and for PD1, that is D1P, for PD1 we can write Na1. So we write Na1, but from the figure you see Bn plus Na1, Bn plus Na1 is nothing but Ba1. So we write it as Ba1, because Bn plus Na1 is nothing but Ba1, and that Ba1 that proves that Ba1 is equal to B1, RHS of equation 1. So this proves that the ray traveling through dP reaches D1 in the same time in which the ray traveling from B reaches point A1 and ray traveling from A reaches point B1. That means A1, D1, B1 is truly representing the reflected wave front. And so we have proved using the Huygens principle the laws of reflection, and of course you see the plane of incident ray, reflected ray, normal lie in the same plane of the board, and so we have proved the laws of reflection using the Huygens principle for light. That's all for today. Thank you and have a nice day.